In this video, we're going to see a quick overview of physical changes and chemical changes. So these are the types of changes that can happen to matter. And there's really two main types of changes that you can see. You can see the physical changes, and then you can also see what's called chemical changes. So physical changes are changes that you can do to matter without changing what the identity of it is. So for example, if I take some water, I'm going to write it out as a formula here, water, as ice in its solid state. That's what the S means there. And I apply some heat to it. It's going to become liquid, H2O as liquid. But here's what I want you to notice. Water in its solid state is still H2O. I'm drawing this out here. You don't have to know how to draw it out, but I just want to show you it's still H2O chemically speaking. It's H2O chemically combined like this. Water in its liquid state is still H2O chemically speaking. It's still the same molecule. It's just now in a different state of matter, but it's still H2O overall. So this was a change that happened to the water sample that we had, but the identity, the chemical identity did not change. So a physical change is when you change matter in a way, but its chemical identity is still the same. It's still water at the end of the day. So a great example of a physical change is simply a phase change or state change. When you melt something, when you evaporate something. So when you boil water, it's going from liquid to gas, but it's still going to be water. So for example, if I boil water, so I have liquid water, and I apply some heat to it, it's going to become gas water, right? So gas there, but it's still H2O. Other examples of phase changes might be if you take a piece of paper and crumple it or rip it. It's still not phase change, physical changes, I should say, because that's not a phase change. If you take paper and you rip it or you crumple it, that's going to be a physical change. You didn't change what the molecules of the paper were. If you take a piece of bread and you cut it in half, you didn't change what the molecules and the elements and the substances that make up the bread were on the inside chemically. You just cut the piece of bread in half and you separated some of the parts, but everything is still the same chemically speaking. So physical changes do not change what the substance is on a chemical level, whereas chemical changes will change the identity of the substance. Before we go to chemical changes, I want to do one more that students often forget. If you look at dissolving, when you dissolve something in, let's say, water, that's actually a physical process. It's a physical change that's happening. So if I put some salt into water, these are still salt and water inside. They didn't combine to form anything new. They didn't change their identity. It's just that the water and the salt are just swimming around together now. And that's it. But you still have H2O and you still have NaCl. They're just swimming around together in the glass of water. So dissolving is actually a physical process as well. Now, chemical changes, on the other hand, that does change the chemical identity of our substance. For example, if I take some water, liquid water here, and I apply some electricity. So here, this was heat. I'm just heating it up. Heating up, the triangle means heat. Here, I'm going to apply some electricity to my water. And that's actually going to chemically separate the water into H2 gas, hydrogen gas, and then oxygen gas. So I now have two different substances. I have H2 by itself and O2 by itself. This is no longer H2O. They're not the same anymore, right? This is not necessarily just a change of state. This is a change in the chemical identity. Here I had H2O. Here I have H2 plus O2. So for physical change, I said, crumpling paper, ripping paper is a physical change because it stays the same. But if you burn paper, for example, if you take a piece of paper and light it on fire, the chemicals on the inside are changing into things like carbon dioxide and water and carbon monoxide and regular carbon and soot, a combustion reaction. So you have actual changes happening to the chemical identity of the substance. So generally, for chemical changes, you'll see that a new substance forms. You change the chemical identity. A new substance forms. So when you cook stuff, if you're cooking if you're actually roasting vegetables, or you put bread in a toaster. If you put bread in a toaster, the particles, the molecules are going through reactions and becoming a new substance overall. Whereas physical change, if you just cut the bread, it's still bread. The particles in there are still bread overall. So cooking things or burning things, for example, those are examples of chemical changes. Or if you ever see it that we're reacting, when two things are reacting together. So if I put vinegar and baking soda, the vinegar and baking soda are reacting to create new substances or new chemical identities overall. There's new compounds, new elements that have formed in that reaction. Those are examples of chemical changes as well. So you should be able to identify chemical versus physical changes if you're provided with some scenarios. So for example, let's say that I decide to cut a carrot with a knife. That would be an example of a physical change because the particles stay the same. Now suppose you decide to cook a carrot in a pan with butter. You're frying it, you're cooking it, the carrot starts to brown a bit. What type of change is that? That's right, a chemical change. It's hard to tell sometimes what you're looking at when it comes to chemical changes, if there is one or not, because you don't see the molecules, you don't know if their identity is changing. So there's a few things that you can look at to see if a chemical change is happening. Those are called the clues or evidence of chemical change. Clues of chemical change. And it's not always going to be a giveaway that a chemical change is happening, but they're nice pieces of clues to look at, especially when you're in the lab. So some clues of chemical change that you might see might be a color change. So you have two substances that do not have a color to them. They're colorless. Then when you mix them together, there's a new color that appears. So I take two clear colorless liquids, put them together, and then boom, they're red. And there was no red there to begin with. So a new color has appeared. That means that you have a new substance in there that happens to be red. You might have an odor change. So you might have two chemicals that you mix together, and before you mix them together, they smell bad or they smell weird. Then when you mix them together, they smell like bananas all of a sudden, or they smell like mint all of a sudden. So when you have a change in odor, that often means that you're going to that you have a new chemical in there that formed because of chemical change, and it has a different odor than the initial chemicals that were there. You might sometimes see an energy change. Energy change. So you might see, for example, a change in temperature. So you'll mix two chemicals together, and then all of a sudden they'll get very hot because they release heat to your hands or to the environment. So if they get hot, that may be an indication that there's a chemical reaction happening. And not because you're adding heat. So putting water on the stove and heating it up and saying, oh, water got hot, so it's chemical. No, this is temperature change without having to add or take away heat. Sometimes you might mix two chemicals together and they'll get cold without you having to put it in the fridge. And that's an indication of an energy change. Or you might see light. Sometimes you might mix chemicals together and they release light. Like if you've ever broken a glow stick or used a glow stick, you crack the little tube and it starts to glow. That's because you let chemicals mix together and they make a new substance that, well, releases some light energy. So you might have an energy change in there as well. You might also see now even though we don't use this very often, you might see a taste change, right? We don't really do that often in the lab because we don't taste things in the lab. But if you ever let milk spoil or a banana rot, a banana rotting will taste different than the banana before it started to rot. And actually, there's lots of indicators of chemical changes when the banana rots. You can see a color change, it becomes brown, it smells different, odor change, you have a taste change as well. So lots of different clues there. And then you might also have a production of a gas production. And we usually see that in the form of bubbles. Now, be careful with this because remember, I said if you boil water, right, you'll see bubbles, okay? But that's water boiling, okay? The bubbles, this is part of our boiling process here. So this is still physical. The bubbles really have to be a new gas being produced. Like if I take vinegar and baking soda, when they react, they make a bunch of things, but one thing that comes out of that is CO2 as a gas. And so the bubbling you see is because of the CO2, the new substance that was formed during that reaction. And that's the CO2 there. So gas production can be a good indication. Sometimes you might smell the gas, which is part of the odor change. Sometimes you'll mix two things together and you get this weird odor that comes out, and it's just a gas that smells weird that comes out. And then you might also have what's called a precipitate, or we sometimes say solid. I'll say solid chunks. So sometimes you'll mix two liquids together. So here I'll just draw a test tube. Here's another test tube. And there's two solutions here. They're basically they look like liquids. And so I'll pour one into the other, and then you'll see these little solid chunks start to form. And those solid chunks are a new substance. And so that we call it a precipitate. So when you see solid chunks, that's a precipitate. Or if you see milk spoil, you get the chunks of proteins and all that in your milk because it's spoiled, it rot. So that would be an example of a precipitate forming. So to really determine if you have a chemical change versus physical change, you need to look at some clues. So in the lab, if we see clues like this, a color change, an odor change, energy change, taste change, gas production, or precipitate, it's a good indication that you may have a chemical change happening and not a physical change happening. Just be careful again with things like bubbling, because if you're heating something up like water and it starts to boil and you'll see bubbles, that's still a physical change. It's not chemical.